Please take your seat. We want to have everybody in place so that we can have our next speaker. Oh man, this is good. You guys are very responsive. Okay, now do I see Ben Bussey? Yes. Ah! That was planned. Okay. Okay, great. All right, thank you everybody for coming back. We are running just a little bit late, but we fixed the problem, we think. So thank you to our tech team. And now we're going to get on with Ben Bussey, who's going to talk to us about the human exploration perspective from NASA headquarters. About the moon.
Right, thank you, everyone. So unfortunately, the flicker is fixed because the flicker was going to be the highlight of my talk. People who say that HEO and SMD don't talk together, don't talk the same language, as I was sitting there realizing how many of my slides were the same as Sarah's, we do speak the same language and we show the same slides. And note to self, asked to go first next year. Yeah. So even though we're up to SPD, it's probably got an acronym, SPD3, SPD1 is still obviously very relevant for this community. And so yes, moon, large, big, good. But the other bit's good too. On the left, we have ISS. We're still going to be using ISS, and we have something there in small font saying notional commercial platform. So as you know, we've been directed to look at ways for commercialization for stations such that from roughly 2024 onwards, the government isn't the only customer. Whatever happens to ISS, we always envision that as NASA, on the HEO side, we will want a low Earth orbit presence. So that's something that's being considered. And Mars is there on the right because Mars is still the horizon goal for human spaceflight. But in the near term, and most of what I'm going to talk about today are the near-term lunar activities leading to people on the moon as soon as possible. Yay, new different slide. So the NASA lunar exploration, and so this is the list of missions either ongoing or future missions going out roughly the next 8 years. Sarah talked about the small commercial landers, the CLIPS program, starting from as soon as next year onwards. In HEO, we've been directed to concentrate on the mid to large size landers. The plan is we have 2 landers being planned. The first is in 2022. This will have a 500 to 1,000 kilogram class payload capacity. This then moves on to 2024, where it grows slightly, leading on to here to notionally 2026 onwards. We're going to be designing the landers from the very beginning, which are scalable to human-class landers. And you need roughly 5,000 to 6,000 kilograms of surface payload if you're thinking of a crew of 2. That's the sort of the nominal size. And so we are looking at doing HEOs concentrating on those landers. In orbit, we have the Lunar Gateway, and I shall be talk more about that. But you can see the first part of that, the power propulsion element, goes up fairly soon in 2022. How exactly, with the small commercial landers, those are provided by commercial partners, and we will be one of many customers flying payloads. How exactly that works with the HEO larger lander is still being worked, the exact component of what is the role the industry will play. So one of our near-term activities, I always put this slide last, and I always run out of time, so I thought it's only fair just once to put it early. The Koreans are flying the KPLO lunar orbiter scheduled to launch in December 2020. We have an agreement with them for the last couple of years, and we're very excited to be flying an instrument called ShadowCam. Mark Robinson is the principal investigator. This is a modified NAC, narrow angle camera from LROC. It's 800 times more sensitive than the LRO NAC, and it essentially will use reflected light from the inner rims of permanently shadowed craters to map the floor of these craters at better than 2 meters spatial resolution with a signal to noise of greater than 100. So the idea is to map albedo patterns, to look for any potential surface volatile exposures, investigate some of the craters that look very interesting in the mini-RF data. We can now map out the actual boulder distributions and see what component of the mini-RF data comes from boulders versus buried ice. We want to look for any temporal changes in albedo and also look at the morphology within the permanently shadowed regions to see whether it's indicative of a regolith volatile mix. So exploration mission 1, the first launch of SLS and Orion, is scheduled fairly soon now. It will be uncrewed. It's about a 25.5-day mission. They both go out to a distant retrograde orbit and then come back approximately a month later, testing out all the systems. However, we're going to do good science and exploration with this. I know I won't spend too much on these. Barbara Cohen's giving a talk on these today, but we are flying 13 CubeSats on EM1. The ones in yellow here are the ones that are sort of lunar focused. These are coming from a mixture of HEO, SMD, and also JAXA, which has Omotenashi, which is a very exciting one, which is actually a hard lander in a CubeSat form. Following on from this will be the first crewed flight of SLS with Orion, and this will go and do a far side lunar flyby before coming back to Earth. It's roughly a 9-day mission. So then onto the Gateway, which I'm very happy to say is now just called Gateway and not Lunar Orbital Platform Gateway. Never see those words again from here. So here is the Gateway development. This is nominally it's a handful of modules. We have the power propulsion element going up in 2022. For this community, it's important to realize that this will have a comm relay capability, including the idea it will have a communication dish which is dedicated towards pointing towards the moon. And it will also have data storage and a relay capability. This will then be augmented by habitation and logistics modules, including an airlock. We're envisioning a crew of 4 staying for initially roughly 30 days. This is very different from Station, which has been permanently occupied for many years now. At some level, this is an untended platform which will be visited by crews nominally once a year. And the reason I mention that is that makes it quite different from a science utilization opportunity. So we studied this briefly as part of the HEO side of NASA, as part of the International Space Exploration Coordination Group. And this is a non-binding group of space agencies where we get to talk about potential future planning. And recently we did a white paper where we looked at the science enabled by human exploration to different destinations, including asteroids, lunar surface, and a gateway in lunar orbit. And lo and behold, now that we have a gateway in lunar orbit, we leveraged this work to do a more detailed study of what type of science would we like to do on the gateway, what science does it enable, and we had this workshop back in February, and so the idea was to engage the science community to make them realize that this thing is going to exist, how might they want to use it. We want to understand the scope of the instruments that the scientists would like to fly, and that's useful for SMD for thinking about how do they facilitate those instruments flying. And then on the HEO side of the house, we wanted to better understand what resources does the Gateway have to provide in order to enable that science. You give me a 2-minute when it... Oh. So it was very well attended. We had about 300 people. We had 5 parallel science sessions based on the SMD divisions and life sciences and space biology, and then we had some cross-cutting sessions that looked at it from a HEO perspective to try and summarize the resources that we would want to do. So the top-level science takeaways, was that the Gateway, it will nominally be in a near rectilinear halo orbit. So this is a roughly 7,000 by 70,000 kilometer orbit, which it's one of the family of, it's in the same family of orbits as L1 and L2. It actually goes around the 90-degree, plus or minus 90-degree longitude line. So you actually have full visibility from Earth. And the Earth heliophysics and astrophysics and fundamental physics communities, we were quite taken aback by how much interest there was in a platform around the moon. Having expected to be some interest in, I guess if you do it, we might bolt something on. Particularly the Earth and the Helio folks, they were really excited about, you've got this entity, this asset 400,000 kilometers away, where they think that actually provides a unique science opportunity. You can obviously do a lot of good lunar science with something around the moon, but surprisingly, you actually need more transportation infrastructure to really to maximize the lunar science potential that the Gateway enables. We've already started to think about a lot of the lunar science that was proposed really would like to either be done in low lunar orbit or have access to low lunar orbit. So we're starting to think about in HEO potential ways of getting regular low lunar orbit access from the Gateway. One potential is the logistics module. When it's finished, when the crew have gone and it's finished its primary mission, it's not that hard to have the Delta V capability to go down to low lunar orbit, do some things there, and then come back and potentially be refuelable and reused. And we're very aware that reusable surface global access would be very enabling, both from dropping off instruments to also bringing back samples. A lot of interest in externally mounted, actually collecting samples on the Gateway itself with a variety of different materials. Obviously, the radiation environment outside the Van Allen belt, there's some unique, we're very much focusing on what do you have to do at the Gateway that you can't do on station, and a lot of the radiation experiments fall into that. We realize, the one in italics here is, you have this thing will have international contributions, we'll have different space agencies involved, and we need to start thinking about that. How do we coordinate? It's probably very unlikely we'd have, if we take heliophysics as an example, that you have one big worldwide AO to do heliophysics instruments. That tends to not work. But what we have to do is, if you have, for example, JAXA, ESA, and NASA all doing heliophysics calls, we have to have some form of coordination, because it wouldn't be surprising if all three of those groups, their top-rated instrument ends up being very similar. And so we need, the resources will be precious on the Gateway, and so we need to make sure that we avoid duplication. So my last two, I have last two that just summarize some of the science. So where there were interest in lunar remote sensing, a lot of interest in deploying of CubeSats from the Gateway, interest in telerobotics, both for lunar surface exploration, human-assisted sample return, and also setting up instruments on the surface. There were several abstracts to do with near-Earth objects, where you would actually want to either take key measurements with instruments on the Gateway or bring samples back. And I've mentioned the value of a reusable lunar lander. My last slide is, again, I mentioned that there was interest particularly on the heliophysics side, there's a wide variety of interest related to samples that the Gateway could enable. And I'll leave that up and take questions.
Okay, please come to the microphone for your questions. Thank you for that.
I'm behind
very
you,
nice
just
talk.
a minute. Okay.
I know you're. Okay, Jen.
Hi, Jen Helms, NASA. So I guess this is on a common theme we've been hearing. David Crane mentioned this in his talk and Barbara Cohen's question, but
You're projecting, but not on.
Getting to the strategy of these near-term lunar missions, especially. And so I'm just wondering, how will the HEO interests be included in the SMD-led near-term missions? Because it seems to be somewhat of a disconnect, so I just want to know how it's working at the higher level, since HEO has been investing, I mean, from the outside, it looks to me like for the past 10 years, investing in looking at volatiles at the poles. There was LCROSS 10 years ago, then there was RP, so the money has been invested, but now we're not going there in the near term, and so what are HEOs, what do you really want to know, and how are we going to get those answers for the SKGs?
So I think there are sort of three components to that answer, or at least 2.5. So Sarah touched upon this well when she described the fact that CLIPS, whilst the money is located in SMD, it is very much seen within the agency as an agency-wide, how are we going to get the data sets that the agency needs? And that includes SMD, HEO, and STMD. So we are working very hard on that now to address sort of that. That's one part of it. The second part of it is going to be, Steve Clark's going to be talking here on Thursday. I mean, some of what I picture what he's going to be doing is thinking that big picture strategy. What do we need to be flying, of which CLIPS would be a significant initial part to get the data sets we want to get. And the final part of that is, he is doing the large lander capability in 22 and 24. So we are thinking now, what are the most useful things to fly on those landers from an agency strategy perspective?
Okay, we'll just take the ones that are standing up now.
There's a lot of them.
Okay.
Okay.
So,
Okay, let's go.
so right now you have just the landers going to the moon, Do you have a program for developing rovers that will go to the moon?
So that is something that, again, that's something that has to be considered as part of what is the overall strategy of what you're trying to achieve. I totally agree that, given the data sets we want to get, many of those data sets are either far better acquired with a rover or just simply have to be acquired by a mobile platform. That a rover, a medium-scale rover probably does not fit under the initial CLIP scope when you look at the likely capabilities of the commercial lander folks, but they will likely progress to larger-scale landers, and you've also got the HEO landers to think about too.
Okay, Bill Bakke.
Is there any strategy right now for, so we're talking about commercial landers and doing different things from that, but we also have the Gateway. Will the Gateway be a platform for other more ambitious lunar missions like landers and other such things, or is that envisioned in the architecture right now?
Yes, I mean, it is envisioned, not to be facetious, Gateway is called Gateway for a reason. So yes, it is envisioned as, and the orbit has been chosen. There are many of the lunar scientists would like it to be in a 100-kilometer low lunar orbit, and that is, without doubt, that is an easier orbit for surface access. But the bottom line is, it's the total amount of delta V to get from Earth's surface to the lunar surface. And so if you put the Gateway in a 100-kilometer circular, it raises certain technical issues, not least orbital maintenance and thermal control. And you need a lot of delta V to get there. One advantage of the NRHO is you can get to NRHO with a variety of commercial launch vehicles and international launch vehicles. Yes, it means you need to provide the extra 700 meters per second each way to get to low lunar orbit, and so that you have to be able to do that with your lander. But that's one of the reasons we're looking at potential of a tug that could take landers down to low lunar orbit so they don't have to provide that.
Okay, and the last question, Mike Carly.
Carly last again.
Okay. Actually, I have two related questions that really relate to trying to understand the overall plan. You talked about elements, in particular the Gateway, but for us who are interested in doing science, et cetera, we want to know how the plan is going to evolve. So the two questions are, the first is the timing of the first platform, which is the communication, includes the communication. As I understand your charts and Sarah's charts, that won't occur until after a series of these small commercial, which says to me then that we won't have access to the far side until after the first phase of the commercial.
So let me take that one now. I would say that most of the commercial providers that we've talked to, they themselves are only thinking of near side for their first missions, or if they want to do far side, they will be thinking of their own comm relay. So you're right, okay. The Gateway won't be there, the power propulsion element won't be there until we hope the first of the commercial landers happen.
Well, this gets back to the comm, where the Gateway will have a very significant communication capability, which presumably will be long-term. Is that the only element, and will all the other comm issues be brought by commercial, or is that, in the context of NASA's plan, I'm trying to understand what the vision is in that regard.
So there's two, again, there are commercial entities that are thinking of putting essentially comm relay capability around the moon and selling the bandwidth. Okay, so that one option is the government chooses to buy that bandwidth. The second option is the government sees a need to put its own satellite up because we need a capability that isn't going to be provided by commercial.
Okay, that's very encouraging that that's being investigated. The last one, and I realize this probably opens up a larger questions, but let me just mention it. As we've been discussing this morning, a lot of the really transformative science requires samples. Not everything, but a lot requires samples. And your one bullet on the Gateway says it will allow samples to be brought to the Gateway. How is that plan going to be broadened so that we can be thinking of the kind of science that we're eager to carry out?
So one of the outcomes from the workshop was the interest in the use of Gateway for sample return. So we are feeding into the Gateway engineering, the design, the idea that this is going to be very popular with the science community. So these samples would come back. They would very likely come back with Orion, assuming the Orion has the capacity. The other potential is if there's enough interest in this, then you can imagine an Earth return vehicle, a simple return that can take multiple different samples that have been brought up that comes back from the gateway. So we've seen that there's a lot of interest in this, and we think the gateway can be quite helpful in making it happen. But then you also there is also the issue with SMD, which I think it becomes very interesting for discovery. If once the gateway exists and you can propose to use the capabilities that it has, you probably can't propose something that doesn't exist yet. I think that will open up other opportunities, exciting opportunities, longer term too.
Okay, great. Thank you so much.